Today we will cover different properties about triangles. So we are going to take a look at how to classify triangles, the triangle sum theorem, and the exterior angle theorem. So let's get started with classifying. There are two ways we classify angles or triangles. One is by sides and the other is by angles. So here we go. A triangle is a polygon with three sides. When we classify by sides, we count how many congruent sides we have. So first we have scalene, which means 0 congruent sides. We have isosceles, which has 2 congruent sides. And we have equilateral, which has all 3 sides are congruent. Okay. And I'm going to go ahead and use my congruency symbols for equilateral. These tick marks tell me all 3 sides are congruent. For isosceles, these 2 sides are congruent because the third side has 2 tick marks instead of 1. And for scalene, none of my sides have the same number of tick marks, so they are not congruent. Next, we will classify a triangle by its angles. You can have either acute, obtuse, or right. In an acute triangle, all 3 angles are acute angles. In an obtuse triangle, there's exactly 1 angle is obtuse. And we cannot have a triangle with 2 or more obtuse angles. That is physically impossible to happen. And for a right triangle, we have exactly 1 angle is right, a right angle. And just like with obtuse, it is impossible for a triangle to have more than 1 right angle. We also have a 4th kind, a special kind, an equiangular triangle. It's when 3 angles, all 3 angles are congruent. This comes from the word equi, meaning equal, and angular, angles. All 3 angles are congruent, and they will end up being 60 degrees each. Then we can look at parts of our triangle. The angles inside are called my interior angles. And the angles outside are called my exterior angles. One thing I would like to point out is if we were to look at one exterior angle and the interior angle adjacent to it, meaning this angle out here and this angle in here, these 2 form a linear pair, meaning these 2 add up to 180 degrees. So linear pair along with vertical angles are concepts that will come back in this unit. Alright, so that's classifying triangles. Let's move on to our triangle sum theorem. Triangle sum theorem tells me that in any given triangle, the sum of all 3 angles equals 180 degrees. So we have measure of angle 1 plus measure of angle 2 plus measure of angle 3 equals 180 degrees. That always works in a triangle. We have a corollary to the triangle sum theorem. Corollary is an extension of the theorem. It's what else can we figure out based on the original theorem. So notice down here, my triangle now is a right triangle. It has a right angle. So using my triangle sum theorem, I can still figure out that measure of angle 4 plus measure of angle 5 plus 90 degrees, that's 90 degrees over here, equals 180 degrees. Algebraically, I know I can subtract 90 degrees on both sides to cancel it. Subtracting 90 degrees on both sides, I am left with measure of angle 4 plus measure of angle 5 equals equals 90 degrees. So the corollary tells me, in my triangle, if I have a right triangle, meaning one of my three angles is 90 degrees, then the sum of the two angles, the two remaining angles, is 90 degrees. Personally, I prefer using the triangle sum theorem because this always works, whether you have a right triangle or you don't. So triangle sum theorem. Right, down here are examples. Find the value of x, just like with our angles unit and our transversals unit. We're going to do the same thing over again. Here's my picture. What's my equation? Solve for x. Plug in x to find your angle. Those three things, always. So, triangle sum theorem tells me that I can take these three numbers, these three angles, and add them all up. 8x minus 2 plus another 8x minus 2 plus 7x, and they should all equal 180 degrees. Solving for x, I combine like terms. There's 8x plus 7x. 8 plus 8 plus 7, that's 23x. Then I have a minus 2 and a minus 2. So that's minus 4 equals 180. Working with the algebra, I add 4 both sides. 23x equals 184. And my last step, I divide both sides by 23 to get x equals 8. Right, I'll do another example. So at this point, I would like that you copy down the picture, write your equation, solve for x, and pause this video while you do that. And when you're ready, you can continue. Alright, if you solve this correctly, you should have gotten x equals 13. So our next step is to find the angles. I'm going to go ahead and find the measure of angle ACB, meaning this angle down here. Now that I know x equals 13, I can take that 13 and plug it in for x. Again, I would like you to pause the video and spend a few moments solving for x, then continue when you're ready. Plugging x in for 4x plus 6. Plugging 13, we get 4 times 13 plus 6, which gets me 52 plus 6, which tells me angle ACB is 58 degrees. And that's our triangle sum theorem. So last, we will go to the exterior angle theorem. Okay. The exterior angle theorem tells me that my two remote interior angles can add up to equal to my exterior angle. Measure of angle 1 plus measure of angle 2 equals angle 4. And that's a vocab word. We call these the remote interior angles. Alright, so let's go to the example. Find the measure of the exterior angle shown here. So the theorem tells me my equation should look like 2x plus 70 equals my 4x plus 12. The two remote interiors equals my exterior. Alright, solving for x, I'm going to go ahead and subtract 2x on both sides to get 70 equals 2x plus 12. Subtract 12 on both sides to get 58 equals 2x. Dividing by 2 to get x equals 29. Alright, spend a few moments to look at example 4. Here's my picture. What's my equation? And solve for x. And when you find x, go ahead and solve for the measure of the exterior angle. So pause this video, spend a few minutes to work on example 4. Alright, solving for x, and solving for x should have gotten you x equals 47 degrees. Then, to find the exterior angle, I plug in my 47 in here. 3 times 47 minus 19 gets me 122 degrees as my answer. Alright, example 5 is a little bit more involved, so I will walk you through this. Here we go. So there's a lot of things going on here. Find the values of x and y. I'm going to go ahead and start for x. I have 51 here, 8x plus 3 here. These two are my interiors, remote interiors, and I have an exterior. So the exterior angle theorem tells me we can set up my equation as such. 51 plus 8x plus 3 equals 13x plus 9. Combining like terms, I get 8x plus 54 equals 13x plus 9. I will go ahead and move the 8x to the right because I don't want working with negative x's. 13 minus 8, that's 5x plus 9. Subtract 9 both sides. I get, let's see, 45. And dividing by 5, we get x equals 9. Alright, x equals 9. So to find y, there's two ways we can do it. We can use plug in x equals 9 here to find this exterior angle, and I know this angle, 13x plus 9, and this y are linear pairs. They should add up to 180. Or I'll use vertical angles, which is what I will prefer. So here we go. I want to find my missing angle right here. This missing angle over here. Whoops, right there. Because this is y, vertical angles tell me that this is also y. They're the same, they're vertical. So I will go ahead and plug in my 9 for my x to get 51 plus 8 times 9 plus 3 to get whatever this angle is, plus y should give me 180 degrees. So that's 51 plus 56 plus 3, not 56, it is 72. 51 plus 72 plus 3 plus your y equals 180. Cleaning up, combining like terms. 126 plus y equals 180. Subtract 126 on both sides to get y equals 54. Alright, so I use vertical angles to solve this. We could have also used up here. I'll do the second example. If I were to pick this angle instead, plugging in x there, I get 13 times 9 plus 9 which gets me 126. That tells me this angle right here is 126 degrees. Covering this up, I have 126 and y make a linear pair. Linear pair adds up to 180, so what I can do is 180 minus 126, which also gets me 54 degrees. Right. So there you have a quick recap of the notes that we covered today. We classified our triangles. Then we learned about the triangle sum theorem. Here's triangle sum. And then the exterior angle theorem.